Hi, this is S. Lakshmanachari, working as Assistant Professor in Department of Cybersecurity, Institute of Aeronautical Engineering, Hyderabad. So, in this lecture, we are going to discuss about the instruction cycle. So, in general, we are storing a program in the memory unit. So, program is nothing but a collection of instructions. Okay. So, the instructions are executed by the processor by going through a cycle for each instruction. So see here. So we have a memory. So we are using a memory in order to store the programs. So what is program? Program is nothing but a collection of instructions. So instruction 1, instruction 2, instruction 3, 4, 5. So that means a collection of instructions is nothing but a program. So in this program, so the CPU will execute the instructions one by one. So first the instruction it has to be fetched from the memory, then it has to be decoded, and then it has to be executed. So once the first instruction undergo all these three steps, so fetch, decode, execute, then the second instruction will be fetched from the memory. So in this way, all the instructions in the memory gets executed. So whenever all these instructions will be executed, then that corresponding program will be executed. Okay. So an instruction cycle. So every instruction it undergo a cycle. That means every instruction it has to go through the instruction fetch. So instruction fetching, instruction decoding, and instruction executing. So this entire cycle is called instruction cycle. So instruction cycle. So this we can also call the fetch, decode, execute cycle. Fetch, decode, execute cycle. So it is a basic operational process of a computer in which a computer retrieves a program instruction from the memory that determines what actions the instruction dictates and carries out those actions. Okay. So here in this instruction mainly three types of operations will be performed. One is a fetching. First one is a fetching. So instructions will be fetched from the memory, and after that it determines what actions the instruction has to perform, and finally that operation will be performed. So that is a execution. So by this by combining all these phases, it will form a instruction cycle. So instruction cycle is nothing but it is a time required for the instruction in order to undergo the fetch phase, decode phase, and execution phase. So that is called instruction cycle. So in any basic computer, each instruction cycle it consists of mainly 4 phases. So mainly it consists of 4 phases. So the first phase is the fetching an instruction. So already we have seen in general we are storing the programs in the memory. So the instructions are fetched from the memory. So the first step is fetch an instruction from memory. So what is fetching? Fetching is nothing but retrieving an instruction from the memory. So that is called fetching. So that is a first phase in the instruction cycle. This is a first phase. And after that, after fetch phase, the next phase is a decoding. So decode the instruction. So what is decoding? Decode is the instruction, decoding the instruction and calculating effective address. So decoding is nothing but it will determine what type of operation the instruction has to be performed. So that is a decoding. And also here we need to, in this decoding phase, we need to calculate the effective address. We need to calculate the effective address of the operand. And the third one, read the effective address from the memory. The instruction has an indirect address. Okay. So the third phase is read the effective address. Okay, so this is when we are reading the effective address, so that depends upon the address bit of the instruction. Address bit of the instruction. So if the instruction is having indirect address, then we need to go to the memory and we need to calculate the effective address. So that is a third phase. Suppose if the instruction is having direct address, then this third step is not, the third phase is not required. This third phase only required when the instruction is having indirect address. So whenever the instruction is having indirect address, then we need to go to the memory and we need to calculate the effective address. So that is the third phase. And coming to the last phase, that is nothing but execute. So execute the instruction. So what is execution? Execution is nothing but interpreting the opcode and performing the indicated operation. So that is a execution. That means suppose if it is an add operation, so then it will perform the addition operation. Similarly, if it is having some multiplication operation or increment operation, so like that. So in the execution phase, it will implement those actions. Okay. So these are the different phases of the instruction cycle. So the first phase is the fetching an instruction from the memory, and the second one is decoding the instruction, and the third one is calculating or reading the effective address from the memory, and the fourth phase is executing the instruction. So these are the four main phases of the instruction cycle. So here you can see the diagram. So this is a fetch phase. So it start the instruction cycle. The instruction first it will fetch from the memory, and after that it will be decoded, and after that it will be read the effective address from the memory, then it will execute. Okay, so that whenever the one cycle is completed, it's all these four phases, then the next instruction will be fetched from the memory. So again, the next instruction will be fetched. So in this way, all the instructions in the program will be gets executed. So this is about the instruction cycle. And here note, every different processor has its own instruction cycle, because the number of phases, it depends upon the processor, because some processors are having only 3 phases, but some processors are having 4 phases. So that depends upon the processor type. Okay, so let's see in detail about the instruction fetching. So already we know instruction fetching. Fetching means retrieving an instruction from the memory. Okay, so in this instruction fetching phase, the program counter, it plays a vital role. So here it plays a vital role. It is the program counter. It is a key register. Okay, so what is a program counter? The program counter, it stores the address of the next instruction is to be executed. So it stores the address of the next instruction. Okay, and hence depending upon the value of PC address is sent through address bus to the memory, and then specific instruction is sent back through the data bus. So here you can see the diagram here. So it is a memory. Okay, so in memory we have instructions are stored, and we have a program counter and instruction register. So during the instruction fetch phase, so in the program counter, it stores the address of the next instruction is to be executed. So in the program counter, which address is there? 1000. So 1000 address is stored in the program counter. So that means whatever the instruction is present in that address, that will be gets executed. So this address is sent to the memory. It will this program counter address is sent to the memory through the address bus. So once that memory location is identified using that address, then in that the instruction is there. So that instruction, it will be sent back to the instruction register. So that instruction will be sent to the instruction register through the data bus. Okay. Once that instruction is retrieved from the memory, then that will be placed in the instruction register. So this is a scenario of the instruction fetching. And coming to the second phase, that is nothing but decoding, instruction decoding. So after fetching an instruction, it is decoded from user-friendly language to the machine language. So because in general we are writing the programs using some high-level language, low-level language, or assembly language. So here we are using user-friendly languages, assembly language, or we are using assembly language, low-level language, high-level language. So these are the different programming languages we are using. So we can write the program using any of this language. So these are all the user-friendly languages, because the writing a program using this language is very easy to understand, easy to write and easy to understand. So, but we cannot use the machine language, because as a human we can understand only the user-friendly languages. We cannot understand the machine language, because the machine language is very difficult to understand and very difficult to read also. Only the machines can understand the machine language. So that's why during this instruction decoding phase, the instruction which is written in the user-friendly language, that will be converted into the machine language. So that is a decoding. So which is similar, which is familiar to the processor of computer system. So during the decoding phase, we are converting the instructions from the user-friendly language to the machine language. So that is a instruction decoding. And the next one is so after decoding we have a third phase, that is reading the effective address from the memory. So the third phase is applicable only when the instruction is having indirect address. If the instruction is having direct address, then the third phase is not required. Okay. So after the third phase, so the next one is instruction execution. So what is instruction execution? Instruction, once the instruction gets decoded, the processor then it executes the instruction. So after the instruction fetched, decoded, then the instruction will be executed. Instruction will be executed. So in this phase, the processor performs actions specified by the given instruction. So we have different instructions like add, subtract, multiplication, increment. So like that, different operations are there. So what this add instruction it specifies? It needs to be performed addition operation. So here in the execution phase, it will perform those actions: addition, multiplication, increment, decrement, clear. So all those operations will be performed during the execution phase. So after completion of instruction cycle, the program counter is incremented by 1. So already we have seen previously. See here. So in the memory the program is stored. Suppose if the program contains 5 instructions, so this is instruction 1, instruction 2, instruction 3, 4, 5. So what will happen? So this is a starting address. Let us assume 4000. Next 4001, 4002, 4003, 4004. So at the beginning of the instruction cycle, the starting address of this will be loaded with the program counter. So that means when using this program counter, the first instruction will be fetched. Okay, first instruction will be fetched from the memory. So after fetching, the instruction will be decoded. After decoding, the instruction will be executed. So whenever the first instruction is undergone these three fetch, decode, execution phases, then only the next instruction will be fetched from the memory. So before fetching the next instruction, so the address of the program counter will be incremented by 1. So it will be incremented by 1. So 4000, 4000, it becomes 4001. So now the program counter address becomes 4001. So that means in 4001, the next instruction is stored. So that instruction will be fetched and again decoded, then executed. So like that, all the instructions in the memory will be gets executed. And coming to the registers. So we are in a computer, we are using different registers. So let's see one by one. So first one is a program counter. So already we know about the program counter. So program counter, it increments the counter that keeps track of the memory address of the instruction that is to be executed next, or in other words, it holds the address of the next instruction is to be executed. So next one, memory address register. So memory address register. So this memory address register, it holds the address of the currently executing instruction. Okay. So using the memory, we are performing two types of operations. One is the memory read operation or memory write operation. So when we are performing memory read and memory write operation, so that corresponding address, memory address, will be stored in the this memory address register. Next, memory data register. So this memory data register is a two-way register that holds the data during fetched from memory or data waiting to be stored in memory. Okay. So this memory data register, using that memory data register, the data either we can store in the memory or either we can read the data from the memory that will be placed in the MDR register. And coming to the instruction register, so it is a temporary holding for the instruction that has to be just fetched from the memory. Okay, so that means once the instruction is fetched from the memory, then that instruction will be placed in the instruction register. So it is a temporary holding. Then the control unit. So the control unit, it decodes the program instruction in IARE, selecting the machine resources such as a data source register and a particular arithmetic operation and coordinate activities of those resources. So this control unit, it coordinates all the various resources inside the computer. And last one is the arithmetic and logic unit. So this arithmetic and logic unit, it performs several arithmetic and logic operations. Arithmetic operations are addition, subtraction, multiplication, division, and logical operations are and, or, XOR, not, complement. So those operations are performed by the arithmetic and logic unit. And the floating point unit, it performs floating point operations. So these are the various registers. And coming to the instruction cycle. So flowchart. So flowchart for the instruction cycle. So already we know. So mainly the instruction cycle, it is having 4 phases that are fetch phase, decode phase, reading the effective address from the memory, and the last phase is the execution. So see here. So using the sequence counter. So using the sequence counter, we are generating the timing signals. Okay. So whenever we apply a timing signal, whenever we are applying a clock to the sequence counter, then it will generate a timing signal T0. Okay, T0. So what is during T0? What will happen? So during So during T0, what will happen? The instruction will be fetched. So instruction will be fetched. So that is the first step. That is the first phase in the instruction cycle, fetch phase. So fetching. So what is fetching? Fetching means retrieving an instruction from the memory. Suppose if you want to read an instruction from the memory, we require the address. Okay. So that address is stored in the program counter. So from the program counter, that address will be loaded into the address register, because using the address register only we can communicate with the memory. So that's why the program counter address, it will be loaded into the address register. So this you can understand with a example. See, consider a memory here. Okay, so the memory, it is having some memory locations: 4000, 4001, 4002, 4003, 4004. Let us assume the program is having some 5 lines. Okay, 5 lines of program. So what is the first instruction? Move AL comma 05H. So that is the instruction stored in the memory. So in order to retrieve that instruction from the memory, first we require the address of that instruction. So what is that address? 4000. So initially that will be loaded into the program counter. So from the program counter, that address will be loaded into address register. So once the address is loaded into the address register, then we have to read the memory. So we have to read the instruction from the memory. So that's why what is the operation? Read operation. M of AR. That means we are reading the instruction from the address which is stored in the address register. After reading, that instruction will be placed in the IR register, instruction register. Okay, so that is a read operation. After reading, what will happen? Then we have to increment the program counter. So now the program counter address will be 4000. This one. After the instruction is fetched, or after the instruction is fetched from the memory, then the program counter value will be incremented by 1. So now the program counter, it holds the address 4001, because whenever the first instruction is fetched from the memory, then decoded, then executed. After that, whenever the first instruction undergone all these 3 phases, the next instruction will be fetched from the memory. So that's why the program counter will be incremented by 1, so that it becomes 4001. So that is a fetch phase. So here it is a read. It is a reading. Read the instruction from the memory. Next phase is a decode. Next phase is a decoding. So what is decoding? So decoding means interpreting the opcode. That means during the decoding phase, so it will determine what type of operation it has to be done. Okay, so that is a decoding. And the decoding, in this decoding phase, our user-friendly language will be converted into the machine language. Okay, so see here. So decoding phase. So during decode phasing, what will happen? See here. So IR of 12 to 14. IR of 12 to 14. So whenever the instruction is fetched from the memory, that will be placed in the instruction register. So let's see the instruction register format. So this is a instruction register. The size of the instruction register is 16 bits. So 0 to 15. So total it is having 16 bits. So the 0 to 11. So this field, it represents the address. So after that, the bits. So 12, 13, 14. So this 3, it represents opcode. That is a opcode field. That 3 bits, it represents the opcode. And the last one is it is a indirect bit. Okay, so that is usual indirect bit I. Indirect bit I. So this is I is for memory related instruction. So when the 15th bit is equal to 1, that means it is the instruction is having indirect address. If the 15th bit I is equal to 0, that means it is having the direct address. So if the 15th bit I is equal to 1, that means indirect address. So that we need to go to the memory in order to read the effective address from the memory. Okay, so these are the 3 opcode bits. So opcode bits are 12, 13, 14. Okay, so total 3 bits are there. So with the 3 bits, so how many operations we can perform? 2 power 3 operations. 2 power 3 operations we can perform. So 2 power 3 means 8 operations. 8 operations we can perform. So what are the input combinations? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 1, 0, 1, 1, 1, 0, all ones. So these are the various input combinations. And it's a decimal value. So when all the opcode bits are zeros, that's corresponding to 0 value. 0, 0, 1, that is equal to decimal 1. 0, 1, 0, that corresponding to decimal 2. Decimal 3, 4, 5, 6. When all the input opcode bits are all ones, that corresponding to decimal value 7. So this is a opcode bits. So here these bits we are decoding. So this decoding will happen during the T2 phase, during T2. So during T0, the instruction will be fetched from the memory. During T1, the instruction will be read from the memory. During T2, the instruction will be decoded. So during decoded means what we are decoding? We are decoding the opcode bits. What are the opcode bits? 12 to 14. 12 to 14 are the opcode bits. What is opcode? Operational code. It specifies what type of operation it has to be performed. So that are the opcode bits. Okay. So the IR of 15 bit will be loaded into I, and IR of 0 to 11 will be loaded into address. So already we have seen here. So 0 to 11 will be loaded into address. 15th bit will be loaded into I, and 12, 13, 14 will be decoded. So that will happen during this decode phase. So once the opcode bits are decoded, then we are checking whether the instructions are what type of instructions. So basically these instructions are classified into 3 types. One is memory referenced instructions, register referenced instructions, and input or output reference instructions. So mainly the total 3 types of instructions are there. Okay, what's the first one? Memory reference instructions. Second one, register reference instructions. Third one, input or output IO reference instructions. So these are the 3 main classification of the instructions. So how we are differentiating these instructions? By checking the D7 bit. So see here. So this is a D7. So based on this D7, we are classifying whether the instruction is a memory reference instruction or IO reference instruction or register reference instruction. So when D7 is equal to 0, then that is a memory reference instruction. Similarly, when D7 is equal to 1, that is a register reference or IO reference instruction. So see here, D7. So D7. So that means it is D0, D1, D2, D3, D4, D5, D6, D7. Okay, so using this D7, we are checking, we are deciding whether that instruction is a memory reference instruction or IO reference instruction or register reference instruction. So when the D7 is equal to 1, when D7 is equal to 1, so that means when all the input, all the opcode bits are equal to 1, then that is a, that instruction may be, that may be a register reference instruction or the IO reference instruction. Okay, so when D7 is equal to 1, that may be a register reference instruction or IO reference instruction. Suppose if the D7 is not equal to 1, that indicates that is a memory reference instruction. So what are the memory reference instructions are there? So these are. So these are the memory reference instructions. That means D0 to D6. So that are memory reference instructions. Okay. And coming to the register or IO reference instruction. So because when D7 is equal to 1, that is a register or IO reference instruction. Again we are checking the I bit. Again we are checking the I bit. So if I is equal to 1, then that is a IO reference instruction. If I is equal to 0, then that is a register reference instruction. So if it is in IO reference instruction, then that that instruction will be executed. That instruction will be executed. Then whenever that instruction is executed, then the second instruction will be fetched from the memory. So that's why the sequence counter will be initialized to 0. So during T0, so if you apply one more during sequence counter 0, the next instruction will be fetched. So here in this scenario, the first instruction is fetched, decoded and executed. So that what is the next instruction? Add AL comma BL. So this instruction, it will be fetched from the memory during T0. Okay. So like that, every instruction, it has to undergo these all the different timing signals. So during T0, T1, T2 and T3. So during T3, it will be executed. Okay, so during T0, the instruction will be fetched. Instruction will be fetched. During T1, the instruction will be read. Instruction will be read from the memory. And during T2, the instruction will be decode. And during T3, so during this is a T3 phase. This is a T3. So here the instruction will be execute. So these are the 4 phases of the instruction cycle. Okay. So we have seen IO reference instruction. Similarly, when I is equal to 0, then it is a register reference instruction. Then it will be executed during the T3. Then the sequence counter is initialized with 0. So that again, it will be, the next instruction will be fetched from the memory. So coming to the memory reference instruction. Okay, so in memory reference instruction also, we have 2 types are there, whether that is a direct memory reference instruction or indirect memory reference instruction. So based on this I, we can decide whether that is a direct addressed memory reference instruction or indirect memory reference instruction. So if I is equal to 1, then that is a indirect memory reference instruction. Indirect. Suppose if I is equal to 0, then it is a direct memory reference instruction. So suppose if the instruction is a direct memory reference instruction, then nothing to do. Then directly it can be executed. After executing, again the sequence counter is initialized to 0, so that the next instruction will be fetched from the memory. So when I is equal to 1, it is an indirect. So that means indirect. That means whenever the instruction is having indirect address, then we need to read the effective address from the memory. Then that effective address we have to place in the address register. Okay, so this is the operation. So for the indirect address, so suppose if the instruction is having indirect address, so this is an indirect address. So this is instruction is a indirect address because we are using a offset of BL. So that we need to calculate, we need to go to the memory in order to calculate the effective address of the operand. Once we have calculated the effective address of the operand, then that address we have to place in the address register. So this one. Then that instruction will be executed. So this is the instruction cycle. Okay, so what is instruction cycle? It is the time required by the instruction in order to undergo the fetch, read, decode and execute the instruction. So in this way, all the instructions one by one, when all the instructions will be fetched, decoded and executed. So in the program, when the last instruction is the halt. So whenever the halt instruction is executed, then the program execution will be stopped. Okay. So these are already we have seen. During T0, the AR is initialized with the contents of the program counter. During T1, the instruction is fetched from memory into the IR register. During T2, the instruction will be decoded. During T3, the instruction will be executed. So based on the D7 and I, we can decide what type of the instruction it is. So when D7 is equal to 0, what is when D7 is equal to 0? That means that is a memory reference instruction. That is a memory reference instruction. When I is equal to 0, that is a direct address, direct. So direct memory instruction. And the execution operation is during T3, nothing to do because it is a direct address. When the instruction is having direct address, you can see in the flow chart. So see here, during D3, what is there? So nothing to do. So nothing means here NOP, no operation. So here D7 is equal to 0, I is equal to 0. So during T3, nothing, NOP. After that, the instruction will be executed. So see here, so during T3, it is NOP, no operation. During T4, the instruction will be executed, then the sequence counter will be initialized with the 0. Next case, D7 is equal to 0. So D7 is equal to 0 means memory reference instruction, and I is equal to 1. I is equal to 1 means it is a indirect. So that means indirect memory reference instruction. And T3, so indirect memory reference instruction. So during T3, what will happen? The effective address of the operand will be loaded into the AR register. M of EA. And during T4, the execution will be takes place. Similarly, when D7 is equal to 1, so D7 is equal to 1. So D7 is equal to 1 means whether it is a register reference instruction or IO reference instruction. And I is equal to 0. Okay. So I is equal to 0. So I equal to 0 means it is a IO type, input or output type. Okay. So what are the input or output type instructions? Input, out, in, out. So that are so during T3, the execution will be takes place. Similarly, when D7 is equal to 1, and then that is a register or IO reference instruction, and I is equal to 1. That means it is a register reference instruction. Register type instruction such as complement accumulator, clear, carry, set carry. And during T3, the execution will be happening. Because see here, For the register or IO reference instructions, the execution will be happened in the T3. So you can see in the flow chart also. So see here. For the IO reference and for IO reference and register reference instruction, the execution will be happen during T3 only. Okay. Okay. So in this lecture, we have discussed about various phases of the instruction cycle, and also we have shown the flowchart for the instruction cycle. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.